how we can create graphs using RStudio. To start with, I went ahead and read in my file called databank, and I called it databank. We can look at the type of data that is in this particular set by using our names command. And if I run that, I can see I have an ID, age, education level, smoking status, exercise, weight, the serum cholesterol, systolic blood pressure, IQ, sodium levels, gender, and marital status. I can run the head to also get an idea of what we have, and this will show us our first few data values. And to start with, I'm actually going to deal with this marital status variable. And we can see, after we read the head command, we see M's and S's and W's. There's also a D. So I'm actually going to start by creating a variable called labels. C to create the list, since I do want to create a list. And I'm going to expand these. D stands for divorced, and since I want to use this as a word, we put it in quotation marks. The M stands for married. The S stands for single, and the W stands for widowed. And it is important that these are in alphabetical order because this is how R is going to interpret them and how it knows which one to do first, second, third, and fourth. I can run this and I can see my labels popped up on my environment window. So now I actually want to create a bar plot. And to create a bar plot, we are going to use the command barplot. Inside of that, we actually don't do a single variable. Instead, we do a table. So I'm going to do table. Inside the table, I need to let it know what data set I'm looking at. That's databank. And then a $sign to let it know which column of that data set that I want to look at, which is going to be the marital status. If I run this, I can see this graph over here in my plots window. I can see the D, M, S, and W. I do want to expand on this a little bit, so we're going to add some things in called arguments. So after my table, I'm going to put a comma. The first one I'm going to look at is main, and I'm going to say main is equal to marital status. If I run this, I can see that I've now labeled my graph. So main tells us what the graph is called, the title of the graph, and we need to put that once again in quotation marks. I want to expand a little more. Like I said, I don't really know what D, M, S, and W stand for in terms of this graph, so I can use this command called names.arg, and then I'm going to set that equal to the labels variable that I created just a minute ago. And I can see that it's going to fully expand these into the divorced, married, single, and widowed. Another thing we can do is label our axes. XLab will label our x-axis, and I'm going to label it marital status. The y-axis we can label using ylab, and I'm going to call it frequency. And if I run this command, I can see my marital status graph where I have labels on all of my axes. Next, I want to look at a pie graph. And for pie, I'm going to use the command pie. And then once again inside that, I need to do a table. Databank lets it know what data set I'm looking at, and then $sign, and we'll go down to marital status so that it can register which variable we want to look at. And if we run that, we can see my pie chart down here. I'm going to use a lot of the same arguments as I did before. I'm going to label this using main. The labels command is actually just labels here. So I'm going to say labels is equal to labels. And if I run this, I can see that I've now titled my graph and gave it the better labels. I can also change the color using COL, stands for color. And I'm going to let that equal to C because I need to create a list of colors. We're going to do a few colors like red, dark orange, gold, chartreuse, and one last one. Forgot that in quotations. So we do have to make sure these are in quotations, and you'll notice mine actually highlighted to let me know what color it was looking at. And these are not the only colors we have. There are an abundance of colors that you can use. And if I click Run Now, I can see the graph changed to the appropriate colors. I actually did not use my last color, but that's okay. We created too many colors, but it is only going to reference the first 4 since there are only 4 variables here. Next, let's look at creating graphs for numerical data rather than categorical. I'm going to actually look at my serum cholesterol. The first graph I'm going to do is a stem plot, and that command is just stem. Once again, I need to tell it my data set, $, and then the variable I'm looking at. And if I run that, I can see my data set here in my stem plot down at the bottom. This also has the command scale equal to, in this case, I'm going to write 2. And if I run that, I can see how it broke it up even better. Before, I had the range of 16 to 17, the range of 18 to 19, 20 to 21, 22 to 23, etc. But down here, I can see how it's broken up. And I encourage you to change that scale value and try some different things and see what happens. Next, let's look at a histogram. For that, we're going to use the command hist. Once again, I need my data set, $, and then the variable I'm looking at. If I run that, I can see my histogram in my plot window. And there's a lot of things that we can do to alter this, just like with our bar chart and our pie graph. I can use main equal to, and I'm going to say this is the distribution of serum cholesterol. If I run that, I can see that it has updated the name of the graph. I can also use things like XLab, which I'm going to call serum cholesterol. I can update the YLab, although I would just call the y-axis frequency, so I'm actually not going to do that. But changing the x-axis does give us more information. I misspelled cholesterol there at the bottom. But it gives us more information on what that data value is. One other thing we can do is use this command in class equal to a number. I'm going to say 10. And this is going to change the number of bins that we have in our data set. Before, it was something that RStudio just detected and decided the best, but we can alter this as appropriate. In this case, I used in class equal to 10 to get 10 bars in my histogram. Next, let's look at a box plot. This command is just going to be boxplot. Once again, I need my data set called databank, $, and my variable. And if I run this, I can see my dot plot my box plot over here at the side. And I can actually also see that I have one outlier. Just like with my other graphs, I can use main to label this. And if I run that, I can see that I have it titled. And I can also title the axes. In this case, I only have one axis, which is on the y-axis. And I can label that appropriately. And if I click run, I can see that update. We can also get some basic information from our statistical calculations. So we have things like this command 5num. And I'm once again going to use my databank set, $, serum cholesterol. And if I run that, I get my 5-number summary, my minimum, my first quartile, my median, my third quartile, and my maximum. There's also a command called summary. And if I do this one and run it, oh, I misspelled summary, forgot the Y. Let's try that again. We can see that it labels each of my values in my 5-number summary, but it also gives me the mean. So I have the minimum, the first quartile, the median, the mean, the third quartile, and the max. I can also use the command mean, and this is just going to output the average of that data value or data set, or the mean. I can use the command min to get the smallest. I can use max to get the biggest. So these two values are in both the 5-number summary, the 5num command and the summary command, but this is another way to get just the minimum or just the maximum. We can also get the median by using the median command. And once again, we had this through other commands, but this is going to input the single number rather than having it inside the list. We can use var. This is going to calculate the variance of the data set. So databank, I'm still using my serum cholesterol. And if I run that, I can see that the variance is 491.3232. Finally, SD is going to calculate standard deviation, which is just the square root of variance. So I could have just taken the square root of my variance, or I can use SD to calculate the standard deviation.